In this video, I want to talk about how we would troubleshoot a PLC input if multiple inputs stop working at the same time. This can happen on almost every single PLC because with all PLCs, even if it's on the card or like in our situation where it's on a designated PLC that has both inputs and outputs, many of the inputs will have some common point, let it be a hot line out in the field or a common line at the PLC itself. And I'll kind of walk you through all of those. So in this case, this is a new setup and a number of our inputs aren't working. And we can see this a couple of different ways. So one of the ways we can tell this is if we open up our input data table file, and we're using RS Logix 500 here, but this would be the same as if you were using Studio 5000, RS Logix 5000, TIA Portal. They're all going to have a place somewhere in the program that lets you see if inputs and outputs are activating. So I know that my read switch here for my cylinder 1, 2, 3, and 4, these are all wired up to the same location. So if I come here and I begin to activate some outputs that'll activate them, I should be seeing some movement in these 4 right here, okay? These 4 should be doing something when I activate certain outputs. So if I come here and I activate output 3, you can see the cylinder moved down, but none of my inputs changed state. So I'll retract this. I'll go ahead and send cylinder 2 out. Cylinder 2 extended, but neither of my read switches worked on cylinder 2 as well. But I can see here that on my input 4, whichever one that is activating. Okay, so now what that tells me is, hey, I have some problems with these 4 inputs. And if I go look at the schematic diagram, you can see here on the schematic diagram that the first 4 inputs all share a common. Now this common is jumped inside of here internally on the PLC circuit board, but right now the common will come into this common screw and it supplies the common for each of the first 4 inputs. You can see here on the schematic that input 0 is showing a pressure switch, but that's incorrect. That's actually the read switch for the first cylinder. So now that the schematic diagram has told me that these 4 inputs share a common, I want to go and troubleshoot from there. Now, one place that you could also potentially start is at the hot, where in this case, the 24 volts is supplied to all of the inputs. But the thing is that I know that these 2 are working. And I can tell that if I come over to here and activate, if I extend that out, you can see that those inputs changed, 4 and 5 changed. Now if I retract it, 5 turned off and 4 came back on. What that tells me is that there is voltage coming to these 2. Now if there was a common jump that was going to supply all of these down to here, then I'd be like, okay, let's try to fix that. But instead, I'm gonna go and look at the common. So I'm gonna zoom in on my control panel here to begin the troubleshooting process. Okay, so my feeling tells me that the culprit is somewhere in this common area, or what we would call our 0 voltage for our 24 volts. I can tell that this should be 24 volts from a visual inspection because the lines here are blue and white with the blue stripe. That would indicate to me that, hey, this is probably going to be 24 volts. So what I'm going to do is I'm going to turn my voltmeter to volts, and then I'm going to hit the select to make sure that I'm getting 24 volts here. Once I'm on 24 volts DC, the first thing that I want to do is come here and check to make sure that I'm actually getting 24 volts and my meter is reading. So I'm going to come over to here, and you can see that I'm getting 24 volts. So I know that I have 24 volts here. So then I want to come to these jumpers. So how this was wired is 24 volts came in from this terminal block here. It's run down and jumped to here, and these four are jumpered together. And then it's individually dropped down to all four of these. With some PLCs, you will see just one common come to here, and then that common is just jumped to each common that is on this list right here. So now the next thing we want to do is we want to make sure there's actually 24 volts coming to here, which I'm 99% sure there is, but let's just make sure. So I'll come in here, check the voltage. Yes, I have 24 volts. So now what I want to do is I want to start tracing my voltage from my 24 volt source that I have here, okay, down. So I come here, 24 volts, 24 volts, and then I want to start tracing it back from this wire, because on the schematic you can see this is the common for all of the inputs that are not working. So I'll come here, I'm receiving 24 volts through this wire right here. I will trace the wire. Now this is almost becomes the moment of truth. If I'm getting 24 volts here, that tells me that there might be a problem with the PLC. If I am not getting 24 volts, then we're going to have to do a little bit of detective work. So I come here and I am not getting 24 volts. This says millivolts here. This is not the 24 volts that I'm getting here. I don't know if you can read this, but there's a volt, millivolt here. When I come in here, I'm getting 26 millivolts. That is something you have to really pay attention to, because you may think, oh, I'm getting 28 volts. It should work. Maybe my PLC has gone bad. So why this is very important is if I was getting 24 volts here, the traces on the circuit board behind here might have gotten burnt out. And if that was the case, that would send us down a whole other area of troubleshooting. But I'm not getting 24 volts here. So I'm looking now at this point probably for a loose wire or something like that that would exist between here and here. And look at that. As I tugged this, you can see this popped right out. And somebody who stripped this, they did not do a good job, or something else happened. Maybe they stripped it too far. They cut it and they didn't realize that everything was in, but it might be too hard to see, but this is pinched right here. So now I know what the problem is. I can come in here and fix it. So I grabbed a pair of wire strippers that I had laying around. I'm gonna come in here. This is 18 gauge stranded. Not the best wire strippers. I'm gonna come here. I'm gonna twist this wire into place. I'm gonna back this screw out a little bit, place it in here, making sure this time that the insulation is not being pinched. And then I'm gonna go in, and if I already know, I wanna get a torque screwdriver, a screwdriver that has the ability to torque a screw to a specific amount of pounds. And I'm going to twist that to make sure this is good. But if I'm in a hurry to get this going and I don't have a screwdriver with the capability of setting the torque, I want to get this tight. I can use a little tug test. And you can see here on the inputs that these are now working. So I can come over to here. I'm going to activate the outputs and make sure that they are all changing. But I can see here on my screen, I'll highlight the 4 that weren't working. 2 of them are already working, but let's just double check. Okay, and 0 and 1 changed places. Come in here. Retract the cylinder, 3 came off, 1 came on. Now I know that my inputs are working and that was the problem. This is a way you could go through and troubleshoot when multiple PLC inputs have stopped working. Look for what is common amongst them, okay? In this case, the thing that tied all of them together was the common going to the PLC, and I just traced the problem out. Now let's say all 6 of these weren't working. Well, the common between them would be the 24 volts being supplied down to here. And that would have led me down checking for the 24 volts positive here, and not the common here, but just because all 4 of these were not activating properly, that sent me down a different path. All right, so again, trust your schematic diagrams. That's very, very important. And use your voltmeter, okay? There's a reason we teach you how to use those, okay? So that was just a quick video on how to troubleshoot a PLC input when multiple inputs are not working, and those multiple inputs are in line with each other. I hope you found this video useful, and if you did, please do me a favor and hit the like and subscribe button. Thank you so much.